Hey guys, welcome back. In the last video, we learned what exactly is generative AI and we saw few interesting applications. In this video, we'll look at the concept of large language models and we see some more applications in natural language processing. So we basically look at large language models or foundation models and how this level of intelligence is possible with generative AI. As we discussed previously, generative AI originated for NLP tasks and then it was evolved into multimodal capabilities. So let us understand how generative AI models work in the NLP and what are foundation models. So what is the purpose of using generative AI in NLP? So the basic idea of NLP is to generate text or speech just like humans. That is the main goal of NLP, natural language processing. Either it is in the text format or it is in the speech format. We need machines to respond just like humans. So we need to generate text or speech similar to how we communicate. The response from the model should be more natural. So the main problem here is data. Unlike computer vision datasets or tabular datasets in data analytics, text data is unstructured because text data or speech data doesn't have a particular order. Okay, the order changes based on the language. Suppose for English, there will be subject, verb, and then object like that. All the placements are fixed. That means it follows a particular grammar, right? Some other languages follows a different set of rules. So the set of rules like grammar and semantics are different for different languages. But there is a concept called context. That means the same word means two different things depending on the context. For example, you take the word plane, P-L-A-N-E. Plane means it can be aeroplane or it can be a surface, right? Depending on the context. So there is ambiguity in the data. Also, the sentences are not fixed, right? A sentence length can be varying from as simple as a single word to large number of words or hundreds of words, right? And these days it has become more complex because we are creating new kind of words. Suppose English. That means you are actually using English letters, alphabets for typing something Hindi, right? So these are some kind of different languages we are creating altogether, charting language. Also, we have so many acronyms like FOMO, right? So all these are making very difficult to handle the data. Another difficulty is storing the context. Context is actually kind of memory you want to keep so that in future you can come back to it to understand the references. For example, you are reading a novel. Throughout the novel, there can be references to different characters using their pronouns based on the context, right? So if you say he or she like that, you can understand whom that is referring to based on the context. That you can understand because you remember the context, right? You have the whole idea so far what the story has happened. How can you make this possible with the machine, right? How can a computer understand these references? Unless you fit the whole novel, right? Whole novel, whole context in the memory of the model, it is difficult for the model to accurately identify the references. So that is one of the biggest challenges in natural language processing. Usually the older models are there, which are RNNs and LSTMs. These models are not able to handle longer sentences or paragraphs. And the recent models are able to handle large context. That means they can handle paragraphs and even books as well. That is a major breakthrough happened. The major drawback of the previous models are fitting the context into the memory. Okay, when I say fitting the context into the memory, we need the model to be able to process the whole book at once, to understand the context properly, to understand all the characters properly, right? But do we have the capability in the models to store such data? If you want to store the whole book, how many characters are there? How many words are there? All of them into the memory of a model. Do the models have the capability for storing? So the transformer architecture is actually introduced to solve this problem. With the help of this transformer architecture, we can fit an entire book into the model memory. And this model architecture is capable of taking that information and building connections between different parts of the book and different characters in the book. So all the models which are coming up or already came are based on the transformer architecture. Okay, so basically In natural language processing context, these models are called large language models. So because it is NLP, these are nothing but language models, and you interact these models in the form of text. So these are actually language models, and these are large models because they can handle huge amount of data. Okay. So these LLMs are actually GPT series. You can take GPT 3, 3.5, 4, 4 Turbo, 4o. All of these are GPT series. Similarly, from Google, and it has been renamed to Gemini. Similarly, Claude series are there. So there are many models that came up which are using transformer architecture as the backbone. So this is a turning point in the research in Gen AI. We will look at the basic details of these architectures in the coming videos. But for now, we will look at some more interesting applications of generative AI, and we will look briefly how these models are used to build different applications. The first application is language translation. So this is one of the major applications of NLP. Take the example of Google Translate. Whatever you type here, it can understand the language automatically. It will detect and identify which language it is, and it can convert that into any other language you mentioned here. Google Translate has been there from some time, but the accuracy of this translation have been improved tremendously with the help of these large language models. Suppose if you are typing 2-3 sentences, it's fine. It used to work fine even earlier. But if you are keeping the whole paragraph or some few pages, or you can directly upload the documents now, and it will automatically translate into the equivalent language here. So all of these capabilities are possible because of generative AI. Apart from language translation, another major use case for large language models or foundation models is for creating content. This we have discussed in the last video as well. So that can be giving customized recommendations or customized product descriptions to a particular user. Basically, personalization have been improved, and also there have been many tools which got improved with the addition of these generative AI models into them. For example, you take Microsoft Suite, PowerPoint or Excel, or all of these are integrated with Microsoft Copilot, which is very helpful in performing day-to-day activities. Similarly, Apple Intelligence, right? Like we discussed in the last video, there are intelligent chatbots, and there are tools for generating the code such as Github Copilot, and there are tools for creating stories and also for summarization of the paragraph or comprehension. So we'll look at all of this in detail. You might have seen e-commerce websites where they show the product recommendations based on your past purchase history. But what if you can adjust the product description as well, and also these photos and descriptions based on your taste? This is happening now with the help of generative AI models. Not only the type of products, and also the description and the visual appearance of the products also are getting personalized with the help of these models. Similarly, if you take Netflix, the movie recommendations are personalized, everyone knows that. But even the preview and the thumbnails are personalized. This is an example. I opened Netflix on 2 profiles. For the same movie, the preview is different. Also, the thumbnails are different for the same movie. Okay, for 2 different profiles. These are some of the examples of personalization. The next set of applications are these kind of tools like Apple Intelligence or Microsoft Copilot. So these tools are deeply integrated into our day-to-day activities and very helpful in doing things faster. These are a couple of snapshots I took. There are a lot of websites came up for creating the presentations automatically based on your prompt. And similarly, this is an example of Apple Intelligence in Apple Notes, and this is in the mail. You can compose the mail with ChatGPT. Also, you can see it is highlighting the priority mails. And similarly, if you select a paragraph, you can actually proofread that, rewrite that in a different tone, or you can get the summary of that, key points, all of this you can do, right? So these are the tools you use day to day, and with the help of these ChatGPT or Gen AI models, we are able to perform the tasks faster and better. Github Copilot for coding tasks. So along with coding a particular module, there has been development in this particular domain, especially helping the software developers, where a Copilot model can completely build the entire project, entire end-to-end project, and deploy it. The functionality or the capability is not limited to just writing a block you are asking for. It can actually write the whole project. It can build the whole project. It can write test cases. It can actually deploy the project as well. So all the applications we have seen so far are amazing and they have improved our lives a lot, right? But how is this level of intelligence possible with the generative AI models? What is so special about them, right? How are these models able to do such tasks? There are many factors for it. It is a combination of algorithm improvements, like advancement in the model, training patterns or designs, etc., and data availability and the computing power. Transformer architecture is definitely the turning point because self-attention mechanism in the transformer model allows to capture long-range dependencies, what we have discussed previously, right? Larger context. You can fit the whole book also into the model and it can understand the whole book as a whole. This has led to the rise of the GPT models, BERT models, all of this. So these are actually called foundation models. Also, it has been proved empirically that bigger models with more data always perform better than the customized or specialized models. OpenAI GPT-3 or GPT-4, all of these demonstrated that larger architectures could generalize well. From then onwards, foundation models became the norm. So what exactly is a foundation model? A foundation model is a large-scale AI model trained on massive dataset. It's just the scale of the model, that's it. You train the model with large amount of data available across the internet so that the model can do all the general tasks very well. These models can generalize very well and it can be adapted to many applications with very minimal fine-tuning. For example, GPT models are the foundation models because they are trained on all the internet data available, right? Suppose if you take GPT-4, it has 100 trillion parameters. Usually our deep learning models, the parameters are in the range of millions. So you see the scale of these models. And these models are trained on large corpus of data. It is trained on all the internet data, GPT-4 or GPT 3.5, right? So automatically they have very good knowledge of all the text across all the languages because it has been trained on all the text data. And these can be adapted to any small task. Suppose you want to do language translation from English to German. Already there is a foundation model which is trained on all the text data. So it has very good information about how the text is in different languages. So it is very easy for that model to fine tune for a particular task like this. Also for document summarization. This, whatever we call this training previously for building the foundation models, this is actually kind of a pre-training. In deep learning also there is a concept called pre-training, right? Before you fine tune the model on your supervised data set, you pre-train the model on a large chunk of data, unsupervised data, which is similar to your domain. So that is pre-training. Similar concept is here. The foundation models are trained on huge amount of data, but it is all unsupervised because you can't annotate or you can't label the whole internet data, right? So it is a way of unsupervised training or self-supervised training. We will discuss about that in detail anyway. So you train the foundation models on the unsupervised dataset available, and then later you can use that model for adapting to any particular task. You take the example of GPT-4. GPT-4 has been trained with different types of data. It was trained with the text data, images, speech, or tabular formats or structured data together, all of them together. It was used to train this foundation model. So I am assuming that this foundation model is GPT-4 here. This is only visual representation. This is not the exactly GPT-4 model. Okay. Now you got the GPT-4 model or any foundation model for that matter. You can adapt this model to all of these tasks. Suppose I want to do one question answering chatbot. I want to build a chatbot which can do question answering. As you already have the foundation model, it is very easy for the chatbot to understand the context and adapt to your domain. Suppose you want to build a medical chatbot, or you want to build a chatbot for e-commerce, or you want to build a chatbot for banking domain. So these are different domains. Obviously, this foundation model might not have in-depth knowledge about all those domains, but this model can easily adapt to your domain by just using a small set of data and fine-tuning it. Similarly, sentiment analysis. As this is multimodal data, it already seen few image data set as well. So I can use that for image captioning or object recognition also. So the same foundation model I can adapt it to different range of tasks. Now in case of NLP, we deal with only text data. We don't have images or videos or any other tabular formats. We usually deal with text data. That is why they are called language models. Suppose you have a lot of text data. You have maybe 1,000 books or some other articles available. You train this language model, or you call this as a foundation model, using self-supervised training. What exactly is self-supervised training? We'll look in the coming videos. But for now, just understand that it is as simple as predicting the next word. You need not to label any data. You have a book, depending on the words it has seen so far, it needs to predict the next word. That's it. That is as simple as that. That is the target of this model. Just next word prediction. So you train the foundation model based on all the data you have. Suppose it can be the complete Wikipedia and maybe some 10,000 books, right? Later, this is only language model, right? This is only trained on text data. So it cannot be used for performing any image related tasks, right? So the adaptation from this can be only for question answering, chatbots, text classification, or information retrieval, or sentiment analysis. Any of these things it can use to adapt to that particular problem. Okay, that's all from this video. Hope you learned something from this video. In the next video, we'll look into the transformer architecture, which is the backbone for all the foundation models. Okay, thank you.